In this video we're going to talk about T-charting. T-charting is a great way to provide evidence to back up a claim with respect to some periodic trend or property. So what a T-chart does is you basically take the two things you're comparing and you look at the number of energy levels they have, the amount of protons they have, and the number of electrons, and you compare them. And we're going to assign a priority order to this. We're going to say that the energy levels is the most important thing when you're looking at atomic size or atomic radius, which then also impacts virtually all the other trends. So then secondary, we'll look at the protons, and then thirdly, we'll look at the number of electrons. And again, this just provides like a nice foundation for you to provide when you're answering a question about a periodic trend or comparing atoms. So the first ones I'd like to compare are sodium and chlorine. Both of them have 3 energy levels. So what that impacts is the amount of shielding they have. Remember, shielding is the repulsion from inner shell electrons on the outermost shell's electrons. So that's going to be the same. But what's different between these two is that sodium only has 11 protons, while chlorine has 17. Therefore, chlorine is going to have a much greater effective nuclear charge, and it's going to be able to pull its electrons in closer. And it does, in fact, have a smaller radius as a result. Then, if these two things were the same, we would look at electrons, but we don't need to at this point. For the next one, sodium versus sodium as an ion. Well, right away, you know that when sodium loses an electron, it actually loses its entire outer shell. So you'd say, okay, sodium, the element, has one more shell or energy level than sodium as an ion. It must be bigger. And it is. And you could also look at the amount of repulsion based on the number of electrons. So there's a couple things in there you could use to support your answer. Chlorine versus chloride, they both have 3 energy levels. Chloride has just completed its 3rd energy level. They both have the same number of protons, but you can see that chloride has that additional electron. And that additional electron provides an increase in the repulsion, causing the radius of that to expand. So again, just a nice little platform from which to jump. And then, if we was just asked to compare oxygen and chlorine. And this is the type of problem I don't want to do too often because we're comparing things where there's 2 moving parts. There's the group, and then there's the period, which are both different. So they have different amounts of energy levels. So according to our general strategy, you'd say that, well, chlorine is going to be bigger because it has more energy levels. However, so if we're comparing sodium and bromine, for example, bromine has 4 energy levels and sodium only has 3. So you'd say, okay, bromine's bigger. But because they're so far apart on the periodic table and there's such a difference in the effective nuclear charge, we would actually say that sodium is bigger than bromine even though it has less shells. So it's a valuable tool for helping explain any of these trends. Now, when we're looking at other things like ionization energy or electronegativity or electron affinity, they're all dependent on the radius of the atom because according to Coulomb's law, you know, the closer 2 oppositely charged things are together, the more strongly they're held. And that influences all those properties. The only other thing you really got to look at when you're talking about electron affinity and ionization energy in particular is the electron arrangement of the atoms or ions you're talking about and the ease or difficulty of removing an electron or adding an electron to the atom.